So to continue here, we might just draw this a little bit differently. So I'm going to do this in red just to correct. Now, this is correct as it is, these triangles, but I think it will look better, it will look clearer if I draw my UX along this axis here, and then my UY down here, perpendicular to the plane down there. So this triangle then makes it a little bit clearer, I hope, because it's just the alternate angle for M there. So we know that this is Vy and this is Vx, and we know that tan of M is also equal to opposite over adjacent, which is Vy over Vx. We can also show that if we use the green triangle here, this angle here is also equal to M, but I think it looks clear with the red there, and I hope it does. So the next part of this question is to think about, what do we know about this point over here? What do we know about this where it strikes the plane? Well, the big thing is, and the most important thing you have to remember, is that because this is our axis now, that's our y, and this is our x, and this is our y axis, that at this point over here, s of y is equal to 0. And then we can just say it at the range. So s of y is equal to 0. So we can let s of y equal to 0 and get a couple of solutions for x. So we'll do that there now. So we've got 0 is equal to 40t minus a half g cos theta t squared. This is a quadratic equation equal to 0. So there's probably going to be two solutions. So always with these, factorise out t first. So you have 40 minus a half g cos theta t, and either t can be equal to 0. That's one solution, which makes sense because at the 0 time, s of y is indeed equal to 0. So this is the solution we're interested in, though, which is 40 minus a half g cos theta t equal to 0. So just moving that around, and I'll just continue this over here. I'll just make a bit of space. So continue that just up in this corner here. We get 40 is equal to a half g cos theta t. Our t is equal to, multiply both sides by 2, 80, and then divide both sides by g cos theta. So we've got an expression for time. Now the important equations, and I'll just circle them for us. We know that tan of m is equal to that, which we're given is also equal to 2 over root 3. It's very important. We've got an equation for Vx. We've got an equation for Vy. We've got an equation for time. So it's just a matter of subbing all these in and trying to work it out. So there could be a bit of algebra to do, but these are the important things that we'll get going at. So first off, we'll work with Vx. Or will I just sub them in straight away? I'll go Vy over Vx is equal to. So taking Vy. Now I've made a little mistake back here. Vx, I've left out the t after that and that, because the v is equal to u plus at. Small mistake, but you can see it here now. So Vx, Vy I'll do in blue, I'll do Vx in green then. So Vy is equal to 40 minus g cos theta times time, which is times 80 over g cos theta. Divided by this, I'll do this in green. We've got 40 root 3 minus g sine theta times 80 over g cos theta, and we know this is all equal to 2 over root 3. So now it's just a matter of solving this equation here. First step would be, and I'm going to just kind of take a shortcut because I'm running out of space, is that we can cancel the g in that, it's divided by that, and the cos theta and that one there. We can also cancel this g and this g here. So I'll write this out again from what we have. We've got 40 minus 80 over 40 root 3 minus 80 sine theta over cos theta is equal to 2 over root 3. Now just remember that sine over cos theta, this bit here, is just equal to tan theta. So we can finish this off then, we can just fill that in. We've got 80 minus 40 is minus 40 over 40 root 3 minus 80 tan theta is equal to 2 over root 3. So multiply both sides by root 3 and multiply both sides by 40 root 3 cos 80. Now I'm just going to make a bit of space here just so I can finish on the one page. So we get minus 40 root 3 is equal to 2 brackets 40 root 3 minus 80 tan theta. Multiplying that 2 in, we get minus 40 root 3 is equal to 80 root 3 minus 160 tan theta. Bring that over and you can subtract them, so you'd have a minus and a minus. That'd be, bring this one over, I'd have 160 tan theta is equal to 120 root 3. So tan theta is equal to 120 root 3 over 160. Divide above and below by 80 there. We get by 40. 4 over 3. So tan theta is equal to 3 root 3 over 4. So theta is equal to, I'll just put a box around this and it's very messy but we can just see it, the tan inverse of 3 root 3 over 4, which works out to be, if you just put that in your calculator, you'll get an angle in degrees.